Pluto, an ex-planet and now the most famous dwarf planet in our solar system, is hiding somewhere far, far away in its dark corner. The temperature of Pluto's surface is freezing. I mean, wow! At first sight, it's just a distant, icy, and barren celestial body. But could Pluto be hiding something? Maybe even life? Scientists found out that, despite it being so far from the Sun, its interior is still warm. It's been that way ever since Pluto formed. Under the haze-layered atmosphere of Pluto, there's a frigid surface full of craters and impure water ice. There's also a large impact basin flooded by frozen nitrogen. And below that icy crust could be an internal ocean. When the surface of a planet stretches, it mostly leaves many fractures behind. The same goes with Pluto. You can see there are numerous cracks across its water-ice crust. They're of all ages. Some even possibly date from 4.5 billion years ago, from the times when Pluto was still forming. The dwarf planet probably grew because it slowly accumulated small pieces of icy material. It condensed during the time when the outer region of our solar system was forming. This process was going intensely and fast enough to melt the base of the icy layer. The surface of Pluto extended as liquid water at the top of the ocean froze onto the base of its ice crust during its first 500 million years. The ocean may have stopped freezing for the next billion years. The buildup of radioactive heat temporarily balanced the rate of heat escape to space. But as Pluto produced less radioactive heat over time, the roof of its interior ocean continued to freeze, and it probably turned into a 120 miles thick layer between the rock and ice. Crusts were the first hint there might be an ocean there. Scientists got the second potential piece of evidence when they realized the icy shell had managed to glide across an essentially frictionless interior and reorient itself. And it's not just about the ocean here. The cool thing is that wherever there's water, there could be life. A potential ocean under an icy crust is not something that possibly exists only on Pluto. Some icy moons of our solar system have it too, like Saturn's moons Enceladus and Titan, and Jupiter's Europa. Enceladus and Europa could both have salty liquid oceans. Plus, they have similar water plumes erupting from their interior. These geysers tell us these moons have their own source of energy, probably because of radiation or gravity. Either way, that energy is what could support life. Have you heard of Ceres? It's our closest dwarf planet, the biggest object in the asteroid belt between Jupiter and Mars, and the first asteroid we discovered at the beginning of the 19th century. People even called it a planet then. Although it's not so popular, there's a possibility Ceres has a subsurface ocean too. Geysers could be the first sign of that. The water vapor plume could be a result of a meteorite strike that exposed subsurface ice to outer space. Ceres may have its own atmosphere too. This dwarf planet is relatively far from the Sun, but its surface temperature could go up to -37 degrees Fahrenheit. At these temperatures, if there was water ice at its surface, it would quickly change to gas, and this could create an atmosphere around this intriguing dwarf planet. Not just oceans, there are many volcanoes across our solar system too. Mercury, Venus, Mars, and Io, one of Jupiter's moons, have them. But apart from the Earth, Io is the only one that has more than 400 active volcanoes. 150 of them erupt at any given time. Scientists suspect there could be some volcanic activity on Venus and Jupiter's moon Europa too. But they can't check if that's true because Venus has an extremely thick atmosphere and Europa has a thick ice shell. And even though volcanoes in other spots are no longer active, we know they used to be because of specific landforms they left behind: hills, valleys, plains, mountains, and especially lava channels. It's like when you're watering your plants on the front porch, you see water flowing down your sloped driveway along specific pathways. This creates small channels, a lot like lava does. Our moon may have also had active volcanoes back in the age when dinosaurs were still roaming around. If they had had telescopes, they might have seen something spectacular: lava fiercely oozing from the surface of the moon. Astronauts took images of Ina, an unusual volcanic deposit on the moon, and there are 70 similar patches in the volcanic plains they found on the side of the moon that faces our planet. Some of them are over 1 billion years old, but some could have been formed less than 100 million years ago, and dinosaurs went extinct 66 million years ago. Speaking of dinosaur extinction, could Jupiter have been the main culprit for that? No one knows where this space rock that hit our home planet 66 million years ago came from, especially with such force. It left a crater off the coast of the Yucatan Peninsula in Mexico, and it probably caused earthquakes, tsunamis, and fierce volcanic eruptions that brought troubles not only to dinosaurs but to nearly 3/4 of all animal and plant life on Earth. But some believe Jupiter was the one that flung the comet into the Earth. Gravity is a tricky force that can make the solar system act like a big pinball machine. Jupiter is our most massive planet, which means it has extremely strong gravity. It's like a guardian of our solar system that kicks many incoming comets away, sometimes bringing them pretty close to the Sun. As they get there, these comets can experience extremely strong tidal forces that break them apart and, in the end, create long chunks of a comet. And one of these chunks probably went towards the Earth. Have you heard of the story of Triton? Neptune has 13 moons, and Triton is the largest of them. It's the only giant moon in our solar system that has a retrograde orbit. It means it circles its parent planet in the opposite direction of its rotation. Scientists believe that's because Triton used to be in the Kuiper Belt, a disc-shaped area located in the outer solar system, past Neptune's orbit. And it's possible that Neptune's gravitational force pulled it out of that region millions of years ago. Pluto may have originated within the Kuiper Belt too. Pluto and Triton are almost the same. They have similar density, mass, and surface material. Now Triton is locked away in synchronous rotation with its parent planet Neptune, far away from what we believe is its homeland. Now, the most distant object we've discovered so far in our solar system is a mysterious planetoid called, wait for it, Far, Far Out. 1 astronomical unit is the average distance between the Earth and the Sun, around 92 million miles. Well, Far, Far Out is 132 astronomical units from the Sun, 4 times farther away than Pluto. Since it's so far away, Far, Far Out needs about 1,000 years to finish a single circle around the Sun. Far out! Have you ever imagined what would happen if 2 gas giants collided? The chances are small, but if something like this happened, not much matter would be lost, although it depends on the angle and the speed of impact. A head-on collision would make them completely merge and not lose any matter at all, whether we're talking about their gaseous envelopes or their solid cores. But at high speed, their 2 cores would merge and both planets would lose most of their envelope gas. At very, very high speeds, bam, both are gone. If there was an oblique collision, 2 cores could completely avoid each other. Planets would merge, but a substantial fraction of their gases would vanish into space. And in a very oblique collision, kind of like a sideswipe, planets would keep going like nothing happened. There's no evidence for that, but one theory even says Jupiter and Saturn, or at least one of them, might have formed by merging from smaller gas planets. Yep, it's all about gas. Frozen plains, mountains with white peaks glistening in the distant sun, and rustic red snow. Welcome to Pluto, where nothing makes sense anymore. Looking at it from a distance, the ice ball planet is mostly predictably winter shades of white and light blue. Once you land on the surface, you'll notice familiar blue skies as well. But see that whale-shaped red stain running along the equator? Right there to the left of the white heart-shaped region, there she blows. This spot is bigger than Alaska, and it's a mystery to scientists. That's not red clay soil or anything you'll see on Earth. That's Pluto's version of ice. Scientists believe it's red because the atmosphere drops this strange soot-like chemical called tholin on the surface. It's the same stuff that explains the red cap on Pluto's moon Charon. Now, let's zoom in closer on the whale. Oh look, we have a mountain range. Yes, Pluto's red ice is like rock, hard enough to form entire mountains. Those white peaks standing out against the dark red aren't snowy caps like we have on Earth. That's frozen methane. For such a small planet, Pluto's mountains are epic, bigger than Everest and made entirely of ice. Such a bizarre landscape can't be found anywhere else in our solar system. Yeah, Pluto's a pretty harsh cold place. Temperatures there can dip to minus 400 degrees Fahrenheit. The coldest ever recorded on Earth was in Antarctica, a measly minus 135. Now let's head back to the heart of Pluto. That's actually a vast plain covered in nitrogen ice. Scientists discovered that Pluto's heart makes the winds on the planet blow. Craters are also big, and some of them show signs of filling and erosion. That's something that happens right here on Earth. When land is worn away and shaped by natural forces like wind, water, and ice, that's erosion. So, what makes all this so special on Pluto? It could be evidence of tectonic plate activity. You know, big plates of land surfing on liquid rock, forming mountain chains, breaking continents apart, putting them back together. That's something scientists so far have only ever seen on Earth, not on any other planet in the solar system. Now, looks like Pluto could be more like our own planet. That, and there's water on Pluto, 1/3 of its surface in fact. But of course, it's not like Earth water. It's more like a rocky slushy. Yum. Still, no signs of life out there, at least not for now. It's taken a long time to get the little information we know about Pluto. It was first discovered almost 100 years ago and deemed the 9th planet from the Sun, until 2006 when its official planet membership card was revoked. Poor Pluto. It was dubbed the biggest dwarf planet in the Kuiper Belt, a region outside our solar system full of other dwarf planets and icy bodies circling the Sun. A few months before that, they launched the New Horizons mission. It was the first space probe researchers sent to Pluto in 2006. Zipping at over 35,000 miles per hour, that's 45 times the speed of sound, it still took the probe almost a decade to reach its destination. That's how far away the tiny planet is. In fact, Pluto is nearly 40 times the distance from Earth to the Sun. If you were there looking up at the sky, you'd see the Sun as a tiny dot like any other star in the sky. Once New Horizons finally reached Pluto in 2015, it got close enough to get some incredible pictures of the surface. It also collected important data and observations, like those strange red spots and that heart-shaped region. But Pluto gets even stranger, especially its orbit. Most other planets go around the Sun in almost perfect circles with the Sun close to the center. The Sun is nowhere near the center of Pluto's orbit, and the orbit is so stretched out that Pluto sometimes crosses into Neptune's path and gets closer to the Sun than the blue gas giant. So, the unusual effect of the strange orbit? Pluto sometimes has an atmosphere, and sometimes not. When it's closer to the Sun, a thin atmosphere of nitrogen forms. But once the planet starts moving further away from our Sun, the atmosphere freezes and falls to the surface in an ice storm of epic proportions. Pluto is probably a lot smaller than you imagine. If you put it on a map of the Earth, it would only span about halfway across the US. Yet this little planet has 5 moons spinning around it. And life on Pluto would be one endless year for us humans. Imagine no birthdays your whole life. Since it was discovered in 1930, we still haven't seen it complete a full circle around the Sun. 1 year on Pluto is 248 Earth years, and we'll finally see that happen on March 23, 2178. Mark your calendar. Since Pluto got kicked out of the official planet club, Neptune became the last one in line. It's actually a big ball of ice and gas. So, like with the other gas giants, if you try to land on this planet, you just keep going deeper and deeper into seemingly endless clouds and atmosphere. Funny thing about the blue planet, it might not have a rocky surface like you and I are used to, but its surface-level gravity is about the same as Earth's. Same can't be said for any other planet in the solar system. As we make our way closer to the Sun, we pass the next gas giant, Uranus, that non-conformist planet that goes around the Sun basically rolling on its side. One full orbit is 84 Earth years, so you might be lucky enough to celebrate your first birthday in your whole life there. Only one party, so you better make it count. And now we approach the jewel of the solar system, Saturn, the second biggest planet after Jupiter and another gas giant where you'd sink in an endless atmosphere if you tried to land a spaceship there. Saturn is the least dense planet of them all, meaning if you put it in a giant glass of water, it'd float. Those famous rings are made up of dust, ice, and rock. Some as tiny as a grain of sand, others bigger than houses. But get this, Saturn's rings are raining down on the planet, enough to fill an Olympic-sized pool in a half an hour. At that rate, the famous blue ring system will disappear completely in 300 million years. By the way, Neptune, Uranus, and Jupiter also have rings. They're just not as visible and bright as Saturn's. Imagine combining all the planets into one. Now make it 2 times bigger. Still not as large as Jupiter. Scientists called it a failed star, since it's mostly made of helium and hydrogen, just like our Sun. But jumbo-sized Jupiter still isn't massive enough to kickstart the chemical processes that could turn it into a star. It's the fastest spinning planet, so it takes only 10 hours to complete a full rotation on its axis. Imagine trying to squeeze sleep, work, friends, hobbies, movies, shopping, your whole routine in less than half an Earth day. Magnificent tall mountains, the highest in the entire solar system. The most epic dust storms ever. Deep valleys, craters. I'm talking Mars, our potential home in the future. If you love sunsets, you'd definitely enjoy Martian ones. They're incredibly blue, while the sky throughout the day is pinkish red. Even though Mars is our closest neighbor, from the surface, the Sun would look half the size it does from Earth. So, not as close as it seems. Oh, and if you always dreamed of becoming a basketball player, Mars is your place. The red planet's gravity is only 37% of Earth's, so you jump 3 times higher there. Venus is a planet of extremes. The hottest surface, the most volcanoes, the brightest planet, and the closest one to Earth. It's also the slowest spinning and barely rotates, making a day on Venus last 243 Earth days. You could literally walk faster before the planet makes a complete turn. Venus also rotates in the opposite direction that Earth does, so sunrises are in the west and the sun sets in the east. Mercury. It doesn't have any moons or rings, and we're talking about the smallest planet in the whole solar system. A year lasts only 88 days, so if you live there, you'd have a lot of birthdays. Mercury is the closest planet to the Sun, but it's actually not the hottest. That prize goes to Venus. Temperatures on Mercury don't get as high as on Venus because it doesn't have an atmosphere to trap heat from the Sun. What Mercury does have is wrinkles. Its iron core cooled and shrank, causing the surface to contract too, and leaving all those wrinkles. That, or because it's so close to the Sun with no SPF. Maybe.
Frozen plains, icy mountains with their snow-capped tops glistening in the sun, valleys, craters, eternal freezing winter.
Wow. Hello there, Pluto. At first sight, it looks like a paradise for adventurers who love skiing, snowboarding, and all the other fun things you can do in snowy winter wonderlands. But the snow there is not like what you can find on the mountains of Earth. On Pluto, the mountain peaks are covered with frozen methane, while down here they're made of frozen water crystals. Because of its specific chemical composition, the snow on Pluto is red. The mountains themselves are very different too. They reach heights of up to almost 10,000 feet. But they're not rocky like ours, looking more like huge blocks of ice. Such a landscape cannot be found anywhere else in our solar system. But you'll need to pack some layers if you want to come visit. The average temperature there ranges from minus 375 to minus 400 degrees. When taking a look at it from a distance, you can see it has some kind of big, heart-shaped thing on its surface, called the Tombaugh Regio. That's actually a vast plain the size of Oklahoma, or Texas, that's covered in nitrogen ice. Scientists discovered this heart actually makes the winds of the planet blow. Craters are also big here, sometimes more than 160 miles in diameter, and some of them show signs of filling and erosion. Erosion is when land is worn away by natural forces such as wind, water, and ice. It's the same process that formed many interesting things that you can see on the surface of the Earth, like valleys, coastlines, peaks, or mountains. The fact that some craters are there because of erosion tells us that tectonic forces must be slowly changing the surface of Pluto. 1/3 of its surface is water, but not the kind that we like to drink, more like a really hard frozen ice. Water is vital for the evolution of life, but not water that's this cold, so it's unlikely that any life has formed here. At least for now. But how do we know all these things about Pluto? Well, here's the basics. Astronomers discovered Pluto in 1930, and just like with plenty other moons and planets, they named it after a figure from Roman mythology, the ruler of the underworld. Pluto was considered the 9th planet of our planetary system until 2006, after which it was recategorized as a dwarf planet. Despite its recent demotion, it is still the largest and the oldest known object in this region of the Kuiper Belt, an outer shell full of other dwarf planets and icy bodies. New Horizons. That was the name of the very first space probe that astronauts sent to have a look at Pluto in 2006. It reached a distance of up to 7,800 miles. While there, it took some important photographs and collected lots of important information, and discovered some of the mysterious cosmic oddities found on the surface of Pluto. One interesting thing about this former planet is that it sometimes has an atmosphere and sometimes not. It has an oval-shaped orbit, which means, unlike most other planets, it doesn't travel around the Sun in almost perfect circles. As a matter of fact, the Sun is nowhere near the center of its orbit. When its orbit takes Pluto closer to the Sun, the extra heat warms up a kind of thin atmosphere made primarily from nitrogen, an element our Earth also has in its atmosphere. Right after it's created, it gradually escapes Pluto's weak gravity. When the dwarf planet moves away from the Sun, the atmosphere freezes and goes back to its solid state, falling back down to the surface of Pluto as nitrogen snowflakes. Pluto's interior is supposedly warmer than its surface. Some believe there's even an ocean deep underground. Despite being the largest known body in the Kuiper Belt, Pluto is still pretty small. It is smaller than the Earth's moon, around half the width of the United States. It has 5 spinning moons of its own, the biggest one half the size of Pluto itself. Our days last 24 hours, while one day on Pluto lasts 153. Earth needs 365 days to orbit the Sun, while a year on Pluto lasts 248 Earth years. So, no birthdays there at all. It sits 3.6 billion miles from the Sun, which is 40 times the distance that the Earth stands. If you were standing there, on Pluto, watching the night sky, you'd see the Sun as just one small distant star, indistinguishable from the rest. Since Pluto has been demoted, Neptune is now the most distant planet of our solar system. It's also pretty fascinating. It's actually a huge ball of ice and gas. Yes, it's the densest gas giant in our solar system, but you still couldn't stand or walk on its surface. You would simply sink in. But if you could stand, you'd notice that the gravity force is similar to what we have on Earth. Despite its impressive size, though, Neptune is not visible to the naked eye from here. It's the windiest and coldest planet. And one year there lasts 165 Earth years. Still no birthdays. It takes more than 4 hours for the light coming from the Sun to reach Neptune's surface. Our next gas giant is Uranus. 1 year on Uranus lasts 84 Earth years, so you can maybe get one birthday in there, but you better make it count. Just like Neptune, Uranus can't be seen without the help of advanced technology. The rest of the 6 planets can. But you can still see all 8 of them with binoculars or a smaller telescope. Now, pause the video, see if you can make your astronomy teacher proud, and try to remember which planet comes next in order from furthest to closest to the Sun. You got it? That's right, it's Saturn. A+. Saturn is the second biggest planet of our solar system, right behind Jupiter. And another gas giant where you'd sink in if you tried to walk on it. It's so gassy, you could put it in a lake and it would float. They call it the jewel of the solar system because it has a big ring system that kind of looks like a crown. Its rings are made up of dust, pieces of ice, and rock. Some of those pieces are as tiny as a grain of sand, while others are bigger than tall buildings. Next on the list, and completing our gas giant quartet, is Jupiter. Scientists call it a failed star since it's mostly made up of helium and hydrogen, just like the main star in our solar system, the Sun. But Jupiter doesn't have a mass big enough to start the chemical processes that turn it into a star. However, it is still the 5th brightest object in the solar system, right behind Mars. You probably have seen it when stargazing sometime, you just had no idea what it was. Okay, picture all the other planets combined and double their mass. That's a lot of mass, but Jupiter still has more mass than that. It's also the fastest spinning planet, so it takes only 10 hours to complete a full rotation on its axis. Our day lasts 24 hours. Imagine how it would look like to squeeze sleep, work, family, friends, hobbies, movies, all that in just 10 hours. I guess I'd have to sleep once every other day if I lived there. Now, picture this. magnificent tall mountains, giant dust storms, volcanoes, deep valleys, craters. Mars. That red jewel scientists keep talking about being a potential new home for us. There were even some small meteorite pieces found on Earth that scientists realized were ejected from Mars. That's how close we are. If you love sunsets, you would definitely enjoy the ones here because they're incredibly blue, while the daytime sky is pinkish red. But when on Mars, you'd only see the sun at half its size compared to what we see on Earth. And of course, there's Earth itself. Seas, mountains, valleys, waterfalls, and of course, life. For 4.5 billion years, Earth has been home to so many different kinds of organisms that have lived, died, and lived again. And even though we know so much about our homeland, there's always something new to discover each and every day. The next planet, Venus, is the champion of superlatives. The hottest surface, the closest planet to the Earth, the biggest number of volcanoes, 1,600. If you compare it to other planets to our solar system, the brightest planet, with reflective clouds that make it so shiny you can see it from the surface of Earth. Oh yeah, and the slowest spinning body as well. It takes 243 Earth days for Venus to make just one single turn. You could literally walk faster than the planet's rotational speed. Venus also goes in the opposite direction of Earth, so sunsets there are set in the east, sunrises in the west. And last, but not least, Mercury. It doesn't have any moons or rings, and it's the smallest planet in our solar system. A year there lasts only 88 days. So get ready to expand that birthday budget. Mercury is the planet the closest to the sun, but not the hottest. Venus took that title. Mercury is not the hottest because there's no atmosphere to trap the sun's heat there. But it does have wrinkles. Only one half of Mercury's surface faces the sun at any given time, meaning there's an incredible difference in the temperature on either side, and of course these sides switch as the planet rotates. The iron core of this planet has cooled and contracted over millions of years due to the rapid change in heat, which is why wrinkles have appeared on its surface. Well, that's a brief tour of all the planets of our solar system. And one dwarf planet. Sorry, Pluto. Thanks for watching.
This is Neptune. The next stop is Pluto. Stand clear of the closing doors, please.
One day, with top-notch future technologies, one stop from Neptune to Pluto won't seem much further than Times Square from Bryant Park today. There are huge ice mountains on Pluto, valleys that go further than your eyes can see, 160-mile large craters, almost as big as the largest one on Earth, and no life. The reasons are obvious. The long distance between Pluto and the Sun guarantees freezing temperatures on that dwarf planet. It also ensures a trip of a few billion miles. Plus, it's smaller than the Moon, so it would get crowded very soon if people started dwelling there. Still, there's one reason which makes life there not that far-fetched. The Sun has a lifespan and cycles within it. Our solar system used to be nothing but a cloud of gas and dust. As a result of a gravitational collapse at the center of this cloud, the gas and dust started gathering in specific, denser places. These pulled more and more matter as time went on, and something called conservation momentum made the mass start rotating and heating up because of immense pressure. Later, there appeared a disk similar to what Saturn has, but it was made of entirely different substances. And right in the center, there was the ball that eventually became the Sun. A protostar is a young star that's still gathering its mass, and that's exactly what the Sun was before the temperatures and pressures inside of it lighted up its core. Millions of years later, it became the Sun we see every day. But it won't stay this way forever. It will heat up even more and eventually get bigger and denser, turning into a red giant. It may one day get big enough to swallow up Venus and Mercury. Chances are, it might swallow even planet Earth. Even if it doesn't devour our planet, the Sun might get close enough to touch us. Well, if this happened, life on Earth wouldn't be possible. But then, in just a few minutes, the Sun loses about 40% of its mass and shrinks about 10 times what it used to be. It's not as bright, and indeed, not as hot as it used to be. By this moment, Earth will have already been deserted. People might want to start traveling around space, or settle down on another planet where life is sustainable, like the exoplanet Kepler-62f, which, by the way, is even bigger than Earth. While all of this was happening, Pluto was changing. Before, every resource was frozen inside of the dwarf planet. Water, gases like methane, carbon monoxide, you name it. But as the sun was reaching its peak luminosity, Pluto was slowly warming up and losing a lot of what it had to the vastness of space. At the same time, an atmosphere formed up. If the atmosphere gets thick enough, it would create favorable life conditions. Then, instead of spaceships, a tiny percentage of us would be able to set up colonies on the dwarf planet. The temperature is comfortable there, almost t-shirt weather. It even resembles Earth a tiny bit. Canyons filled with water, beautiful endless fields with trees, and lots of space to run around, and mineral water pockets on the ground, good enough to drink. Pluto's rotations are different than Earth's. An Earth day is 24 hours, and sometimes it still feels like it never ends. But on Pluto, a whole rotation around the sun takes 153 hours, because it's pretty far away from the sun. After several hours without sleep, we get tired and our eyes get red. It means we'd have to take several naps throughout the day on Pluto. A year on Pluto equals 248 Earth years. Unless we come up with some sort of technology to get us to live that long, our entire lifespan would be less than half a year on the dwarf planet. So, houses on Pluto might need to be equipped with cryo chambers. Whenever you feel like dreaming for a long time, you jump in it and wake up 50 Pluto days later. On the dwarf planet, there are also seas and beaches, so it's just like a tiny Earth, far away from the actual Earth. The food on Pluto could be tastier. We might find a way to make the ingredients more savory and even try to grow them faster during the trip. You plant a carrot, and 2 days later, it's ready to be in your salad. There could also be new ingredients for our salads on Pluto. Maybe 2-meter-tall mushrooms we've never seen before. The animals we would take with us on the trip would get released into their new home forever. And with time, they would evolve and adapt to their new environments. The law of the jungle could change a bit too. Lions might not be kings anymore. Deer are. Their antlers are twice the size of what they used to be. But to be fair, so are the deer. Most of the animals that were already here used to live underwater. But with time, the amphibians started shifting to the surface, just like Earth at the beginning of life. Pluto could only be a temporary home though. Once the sun has finally reached its final phase, Pluto would get frozen and lifeless again. People instead would need to try to find a planet that stays in the Goldilocks zone of another galaxy. The Goldilocks zone is the exact proper distance from the star like the sun, where the temperature is perfect for the water to stay liquid. It's the rule scientists search for when looking for other planets that can sustain life. We can try setting new colonies on one such planet, or even try to set up our own artificial home, not exactly a planet or a spaceship, but a combination of both. Something huge built right in space, say a wheel with gravity everywhere we go, so we don't fall off. It would float in space toward the new exoplanet, capable of fitting entire states in. This whole trip might happen just because the sun first grew too much, and then, having reached the culmination of its life cycle, it would finally become a white dwarf. It's going to be a pretty long journey, and entire generations will be born here. You'll have a choice: sleep your way through the journey until humans finally reach their new exoplanet, or enjoy the trip in this fantastic spaceship. There's all you need on board: malls bigger than those on Earth, large futuristic cities, even places to farm, fields with rich soil made artificially, and finally, after a long journey, the exoplanet. It's even somewhat better than Earth. The planet is giant and has more continents. The continent's center isn't as far from oceans, which means there aren't as many desert areas. Though the sun of this planet is an orange dwarf, it's not as hot as our yellow dwarf sun today. It's a bit smaller, but here's the kick: orange dwarfs live somewhat longer. They remain stable for between 15 billion and 45 billion years. Despite that, this new planet is full of rainforests because the planet itself is warmer. It means more biodiversity and creatures we've never seen before. But even if nothing out there is suitable, we could try and terraform this planet instead. If we take Mars as an example, we could create a greenhouse effect by smashing ice-rich comets and releasing ammonia in them, making the planet warmer. We could also start planting trees. We'd probably need some Earth soil to do that, or we'd have to modify Mars's soil to be similar to ours. Sooner rather than later, the atmosphere would be close to the one we have on Earth. We'd be able to breathe too, because of the trees. Then, we can melt Mars's polar ice caps and voila, water. The problem is the solar winds and sun explosions that might strip it of an atmosphere just as quickly as we can create one, if not faster. It has no magnetosphere either, which means it can't protect us from radiation, so long-term Mars wouldn't be a good choice. Maybe out there, in the vastness that is space, there is a perfect planet waiting for us.
The infinite vasts of the universe hold endless possibilities and secrets. And here's one of the intriguing questions: how life and we as humans would look like on other planets. Imagine a world where the laws of physics, the environment, and the conditions are vastly different from what we're used to. How would we adapt and evolve to survive in these strange new lands? Let's see. Mercury is the closest planet to the Sun and has a thin atmosphere. The temperatures there are extreme, with the day side reaching over 800 degrees Fahrenheit and the night side dropping to negative 290 degrees Fahrenheit. So, what can we do to survive these crazy temperatures and constant solar radiation? Maybe we can magically turn into metal. For example, titanium and platinum can perfectly tolerate high temperatures. But seriously though, there is an option. We could settle underground, where the temperatures aren't so frenzied. If we lived underground, we might evolve with large eyes to better capture light. We might also evolve thicker skin to protect ourselves from the intense radiation. Basically, we have two options: become metal or become moles. Let's move on to Venus. This planet is extremely hostile. First of all, Venus is known for its thick, more toxic than your ex type of atmosphere. The whole planet is covered with carbon dioxide, and its surface is absolutely dry, making it incredibly hot. The average temperature is around 847 degrees Fahrenheit, making it one of the hottest planets in our solar system. Also, don't forget about the crazy pressure. Standing on Venus would be like standing 3,000 feet underwater. Only particular hardy microbes from Earth could survive in such conditions. So, if you want to live on Venus, you might have to become a microbe. But unfortunately, since we're not microbes, we have to wear special gear and equipment to survive there. Maybe we'd have to develop a heat-resistant exoskeleton to protect ourselves, as well as get some new lungs that can filter out the toxic elements in the atmosphere. Let's talk about our favorite red sibling, Mars. The first noticeable change after a few hundred years would be your new skeleton. The gravity on Mars is much weaker than on Earth, so your muscles and bones would shrink. To make up for this difference, you'd have to eat more and probably start going to the gym. Also, you'd have to adapt to the low atmospheric pressure and colder temperatures. You need to retain heat, right? That means you'd need a thicker layer of body fat. Sorry folks, but on Mars, we might become fatter. Another reason to start working out. Another big change would occur in your skin. Your skin is like a big barrier that protects you from harmful things such as bacteria, UV light, looking totally creepy, and so on. So what would happen to it? Most likely, you would turn orange, due to the carotenoids. Carotenoids are a type of nutrient that you get from foods such as carrots, potatoes, tomatoes, and so on. They protect very well against ultraviolet radiation on Mars. They only have one downside. By eating a lot of pumpkins from the Martian farmers market, you'll gradually start to turn orange. But maybe it's not so bad. Maybe life on Jupiter would be easier. Yeah, no, it has no solid land. This planet is made up of hydrogen and helium and is referred to as a gas giant. You would simply float there, like in a huge cloud. And even if you managed to land and tried to walk, it would be like moving through a super thick fog. So how would we evolve there? Firstly, we might become much larger in size to withstand the immense pressures. Secondly, the temperature fluctuations on Jupiter are enormous. The surface is terrifyingly cold and the temperature rises significantly under the outer layers of the atmosphere. Thirdly, if you lived on Jupiter, there would be no verbal language. This gas giant absorbs radio waves, so even if you were speaking, no one would hear you. There would be no music either, so no parties. And what's the point then? Hey, maybe we could communicate with sign language, but that's not so simple either. Jupiter is full of wild winds and storm clouds, so it's unlikely you would be able to see anything. So even if we evolved there in some way, our lives would still not be easy. Before landing on Saturn, you would probably want to check out its iconic rings, but you wouldn't be able to do that because Saturn's rings consist of a bunch of ice particles flying in space, so it would be extremely hard to land. So let's go straight to Saturn itself. At first, it may seem that Saturn is not bad for us. Some layers of this gas giant have quite pleasant temperatures. If we dive deeper into Saturn, it gets surprisingly warm, up to 26 degrees Fahrenheit in its second layer. This is an average temperature in countries like Sweden and Canada. But unfortunately, this is only one such layer. The rest of the planet is incredibly cold, so in order to survive on Saturn, we'd have to do a lot of work. In addition to the cold, we'd have to deal with the planet's harsh environment, including its intense storms, strong winds, and radiation. To protect ourselves from these conditions, we'd need to evolve tough skin, again, find some insulation, and so on. Next planet is Uranus. Uranus has a very different environment from Earth, with much colder temperatures, a lack of a solid surface, and a much different atmosphere. It's like another Jupiter, but with blue vibes. It's not that bad though. There's even water on Uranus. The only problem is, the planet is full of ammonia, that nasty stuff we use for cleaning, so don't be surprised if you feel the gross smell. Also, it's incredibly cold out there, almost like a never-ending winter. So what would it be like to survive in such a dark and harsh environment? We'd need thicker skin, again, to cope with extreme temperatures. And again, we'd need larger eyes to see better in all this darkness. We might even have to develop a new hearing system, like that of dolphins. Wouldn't that be fun? Let's move on to Neptune. If human beings were to evolve on Neptune, they would need to adapt to its harsh conditions. Neptune, the eighth and farthest planet from our Sun, is another gas giant. The only difference is this planet may have a solid core. If we were to live on Neptune, we'd need to float or swim in its methane-rich atmosphere. We'd also need to develop gills or something like that in order to breathe. Basically, we'd turn into space reptiles or cosmic fishes. The gravity on Neptune is slightly stronger than Earth's, but strong winds make it difficult to stand in one place. To withstand the wind, we'd need to be much heavier. Once again, you need to eat a lot and pump up some muscles. Yeah, technically it's not a planet, but we still love it and can't forget it. A small, distant, and incredibly cold world. Pluto's even smaller than our moon, and because of that, there's almost no gravity there. It will be extremely difficult to stand on it. To avoid accidentally flying into outer space while playing football, we need to create a fake gravity machine. And if we don't want to feel dizzy, we need to evolve a brand new nervous system. But Pluto isn't all that bad. For example, there's liquid water under the surface, and even some icy mountains. Maybe it would be possible to survive there if we had some serious equipment, clothes, supplies, and… nah, too much hassle. Anyway, from the scorching heat of Mercury to the freezing temperatures of Neptune, each planet has a unique set of environmental challenges and opportunities for evolution. While we may never truly know what humans would look like on these other worlds, it's exciting to consider the endless possibilities. Never stop looking at the stars and asking these questions.
As you know, all the planets in our solar system orbit the Sun and bring a sense of order to the place. But guess what? There are two planets that could collide with each other and cause a cosmic catastrophe. Here's Neptune, the most faraway planet in our solar system. It's 17 times heavier and 4 times bigger than the Earth. It's 30 astronomical units from the Sun. 1 AU is the distance between the Sun and the Earth, so it's 30 times farther away from our star than we are. And Neptune makes a complete circle around the Sun in 164 years in an almost perfectly round orbit. Neptune is cold, calm, and stable. But there's one planet that can ruin this balance, Pluto. It's a dwarf planet covered in rocks and ice. It's 6 times lighter and 3 times smaller than the Moon. We're interested in its orbit. If you look at a map of the solar system from above, you can see that it's not round but elliptical, so it's a slightly flattened circle. At its furthest point, Pluto is 49 Earth-Sun distances away from the Sun. When it moves, it comes closer to the star. At its closest point, Pluto is about 29.5 AU from the Sun. That's closer than Neptune. So, hypothetically, they could collide. Let's look at this collision from the front row. A little closer, please. Good. Neptune and Pluto are slowly approaching each other. They are both very cold worlds, but they begin to interact with each other gravitationally. Just like two magnets, it warms them up from the inside. Neptune is a gas giant. There's no solid surface there, so there's not much change in it yet. But Pluto has a rocky surface. Because of Neptune's gravitational influence, it's starting to crack. Pluto experiences continuous earthquakes. This causes it to heat up even more. When Pluto almost touches the gas giant, it begins to crumble from the inside out. Plus, Neptune has a very dense atmosphere, so the dwarf planet begins to ignite from friction with the gases in the upper atmosphere. Pluto is now very hot on one side and very cold on the other. This causes severe deformation, and it begins to crumble. Half of the dwarf planet's fragments remain in Neptune's orbit. They will collide with each other until they turn into dust and become new rings of the big planet. Other fragments will burn up in Neptune's atmosphere, and the biggest rocks that remain of Pluto will fall through Neptune until they're completely burned into dust. Neptune literally ate Pluto and continued its orbit without any change, all because the gas giant is 20 times larger and much heavier than the dwarf planet. So this collision would do no harm to Pluto. But it couldn't have happened in the first place, because their orbits don't actually cross. Let's look at the map of the solar system again, not from above, but from the side. All 9 planets here are on a horizontal line from the Sun. The distance between them is great, and their orbits don't cross. Here's Pluto's orbit. You can see that it's tilted relative to the horizontal line of all the other planets. It starts at the top, then dives under the orbits of the planets and comes back. So Pluto can never collide with Neptune. Still, planetary collisions have occurred in our solar system before, and thanks to these collisions, life appeared on Earth. Let's go back in time to almost 4.5 billion years ago. This ball of hot lava is Earth. It just formed from a cloud of dust and began to cool. But then, a wandering planet the size of Mars appeared on the horizon. It's called Theia. It was inevitably approaching our planet. The collision with Theia happened at a perfect angle. If Theia had hit us head-on, both planets would have been smashed to pieces. But it hit us almost at a tangent. Theia knocked some of the matter out of the young Earth and crumbled into rubble itself. It could no longer continue its journey because the Earth caught it in a gravitational trap. A large fragment of this planet remained in our orbit. Smaller fragments crashed into each other, falling to Earth or joining the remains of Theia. The dust settled, and we can see the familiar picture, the Earth and the Moon. This is the main theory of how it came to be next to us. Scientists say that it was this collision that caused life to appear on Earth. Theia brought a lot of ice on it, which turned into water on our planet. The new moon stabilized Earth's rotation, and conditions on the planet became perfect for the emergence of life. Another collision could create a blast wave that would spread out thousands of light years. Stellar collision. This usually occurs in binary systems with a white dwarf and a regular star like our Sun. A white dwarf is the remains of a star that has gone out. As the stars get together, they start to move around each other in a spiral-like dance. The white dwarf pulls down the upper layers of the larger star. This hot plasma and stardust form a luminous disk. The two stars get closer and closer. When they finally merge, this causes a chain reaction in the core of the hot star. The mass of matter presses on the star's core too hard. This causes the innards of the combined star to heat up even more, and it expands, creating a supernova. This is one of the brightest events in the universe. The light from the explosion can be seen hundreds of light years away. Another spectacular view is the collision of a star with a black hole. Black holes are the heaviest objects in the universe, and their gravity is incredibly strong. So when a star and a black hole get close, the black hole starts eating the lighter matter of the star. The hot plasma, like spaghetti, heads toward the heart of the black nothingness. For an observer, this plasma seems to settle on the very edge of the black hole. It's called the event horizon. The thing is that time is much slower near such a heavy object, so we think the matter stays on the event horizon, but in fact it's long gone into the heart of the black hole. As they get even closer, the black hole starts to literally tear the star apart and swallows it whole. At this point, the black hole spits out about half of the star's mass in the form of a beam of energy right out of its black heart. The other half of the star's mass becomes the black beast's food. We know of many black holes in our universe. The heaviest of them usually lies in the centers of galaxies. They can be millions of times heavier than the Sun. But what would happen if two black holes collided with each other? Our scientists had the opportunity to observe such an event. Two black holes weighing 66 and 85 solar masses gradually approached each other. They danced together, bending the light passing by them. But then they merged into one enormous black hole, weighing 142 solar masses. That same second, the new black hole released gravitational waves into space with an energy of 9 solar masses. Scientists were able to catch these waves and observe the merging of the two black holes from the front seat. But this event actually happened about 17 billion years ago. We're only now seeing it because the particles of light and gravitational waves took so long to travel the distance of 17 billion light-years to Earth. Now consider a galactic scale collision. Literally, it's a collision of the Milky Way and the Andromeda galaxy. This event will happen in 4.5 billion years, so stay tuned. The Milky Way has almost 100 billion stars. Andromeda has about 1 trillion. As the galaxies approach one another, they'll make several circles around each other. At that time, some stars may be ejected from the galaxies like from a slingshot. Then Milky Way and Andromeda will begin to merge. One scenario here is that our solar system will collide with another star system from Andromeda. In this case, there could be a stellar collision and a supernova afterwards. Our world would be destroyed. Another option is that the Sun would be ejected into dark space. In this case, we may not even notice the difference. All we'll see on Earth is a gradually disappearing starry sky, as our solar system will travel through dark space away from the home galaxy. But the most likely scenario is when the galaxies merge, it'll be completely painless for us. In fact, the space is very wide, and there's room for all the stars from both galaxies. The only difference is that we'll see a lot of new stars in the night sky, along with flying saucers from Andromeda. Nah, not really. But it's not the collision of galaxies that we should be worried about, it's our Sun. In 4.5 billion years, it'll become a red giant. It'll expand, swallowing up the nearest planets. Earth will probably be the first planet near the Sun. It'll be so hot that all life will simply disappear, and no one will be able to watch the galactic collision.
What would happen to us and our planet if it became as big as the Sun? The diameter of the Earth is 8,000 miles. Crossing it is like driving back and forth across the USA 3 times. That doesn't sound like much, right? Well, how about repeating this journey 305 more times? Just imagine the gas expenses. This is the diameter of the Sun, about 865,000 miles. Compared to our Earth, the Sun is unimaginably huge. So what will happen to us if we catch up with it? There are 4 possible scenarios, depending on what we mean when we say the size of the Sun. Scenario 1. The Earth becomes as large as the Sun, but its mass remains the same. A colossal planet with the mass of a teeny tiny Earth. First, say bye-bye to gravity. The more massive the planet, the stronger its gravity is, and vice versa. Such a lightweight planet simply wouldn't be able to attract anything to itself. Gravity creates all the heavy substances. Everything, from pebbles to entire continents, is held thanks to it. I believe you've already guessed what would happen without it. We'd all turn into dust particles. Yes, the Earth simply becomes a dust cloud. Oh, and to add fuel to the fire, the gravities of other planets stretch us to the sides, leaving no chance to collect our planet back together again. this scenario doesn't look very good, does it? By the way, even if the Earth somehow remained a planet, life couldn't have originated on it in these conditions. There would have been a considerable distance between the center of the Earth and its surface. And remember, the planet's mass is minimal, so no gravity. It just wouldn't be able to hold the atmosphere. And without the atmosphere, living organisms cannot develop. Not like it would have mattered. The Earth now is a cloud anyway. So now this cloud, weighing about 10 times heavier than Jupiter, is gathering in space. As a result, it collapses and turns into a star. Say hi to the new sun. Scenario 2. This works both as a separate scenario and as a result of the previous one. The Earth becomes as large as the sun and gets its mass. Now we have two suns. We become a so-called binary star system. You know what that means? It's time to destroy our entire solar system. Imagine having two centers of mass in one system. The planet's orbits become unstable, perturbed by such a sudden change. Once they get closer to our ex-Earth, they collapse immediately, either from tidal forces or the ex-Earth's impact. Yes, even gas giants. Looking at you, Jupiter. Do you know which one survives and finally gets its revenge on us? Pluto. It would probably be the last remaining ex-planet in the entire system. It's too far away to notice any changes, except for an increase in the mass of the center of the system. So Pluto's orbit comes closer to our two-star system, and that's it. The Earth and the Sun would have to accept that Pluto would be their only friend now. The protoplanetary disk that formed our system billions of years ago doesn't exist anymore, so no more planets can be created in our system. That's all well and good, but what about the Earth itself? What would life be like? Let's see. The nights and days now last longer because of the increase in the Earth's rotation time. There is probably a significant temperature drop in the North and South poles. Even on our current small planet, they get sunlight scarcely. So if the Earth's size increased, the area of the poles receiving sunlight would decrease even more. On a positive note, there's a lot more space now. No more overpopulation. The planet's size is so huge that it would take you years to get from one point to another. Yeah, if you think about it, we'd probably be very lonely there. But hey, who knows? Maybe rockets would become our primary means of transportation. Yeah, that would have been cool. There are many vast uncharted areas that no human ever saw or visited. We also wouldn't know about the existence of many different civilizations and tribes. Centuries pass, and many of us go away without ever meeting other people or learning about them. And that's if we can walk at all. Our bones cannot support our weight with such a considerable gravity, and our hearts have to work twice as hard to keep us alive. The birds can't fly anymore. Nothing can, precisely. All the existing trees fall down, and the new ones grow very close to the Earth, like grass. Talking about the trees, how is our ecosystem doing? Well, not good. If we don't appreciate the environment on our small Earth right now, imagine what would happen if we had such a massive space at our disposal. I even assume that our tons of garbage would have overpowered even those endless supplies of trees and clean water that we would have in our new large home. Our machines and robots have to be huge to do at least something now. That's because even ordinary farms now are the size of the US states. I also assume that it would be much darker than we're used to. The Earth is so small now. Imagine what would happen when our planet becomes the size of the sun itself. Less sunlight means that we'd probably need an artificial sun. Also, the temperature differences on the planet's surface would be huge. If you're surprised, you probably underestimated the size of the sun. It's almost 110 times larger than the Earth. Our new Earth's equator equals our current Earth's 35 equators. Oh, and remember Pluto? Well, it's our only moon now. The first one would have probably crashed into us a long time ago. making us share the fate of the dinosaurs. In that case, all the water would likely evaporate from our planet. Anyway, there are thousands of bad possibilities, but let's just move on and focus on something good. Scenario 3. Same thing, but the Earth retains its density. Now this one is interesting. We're no longer a planet. We're a star now. In fact, we became even more massive than the Sun. Our planet now has a 3.9 solar mass because we need to balance our low density somehow. In short, it would be almost the same as in Scenario 2, but with more interesting long-term consequences. Since our Earth became 4 times as massive as the Sun, it would have burned its fuel quicker. Then it would evolve, and depending on the mass of its core, it either becomes a supernova or just blows off its outer layers to form a planetary nebula. If it goes supernova, the Sun that was so close to us blasts, and now there is just our ex-Earth, a lonely ball with a teeny tiny diameter of 12.5 miles. We're a neutron star. That is, a star made of degenerate neutron matter. That thing is ultra dense and spins very quickly, so you'd better stay away from it. If the Earth becomes a nebula, the Sun collects all the dust and adds it to its mass. Now we have a slightly more massive Sun and a white dwarf. The time passes, and Grandpa Sun lives out his life. It becomes a red giant after depleting the hydrogen in its core. It starts expanding and leaves its material, mostly hydrogen, on the white dwarf. That's us. When the matter reaches high enough temperatures and pressures, nuclear fusion happens. We become a nova. Yay, we're a star again. A lonely one, but a star nevertheless. So what happens next? You see, a star is a battle of opposing forces. One of them is gravity, which tries in every possible way to compress the lead into a small ball as much as possible. The second is a pile of fuel in the star's core, which, while burning, forms tons of energy and substantial hot temperatures. As long as these forces are in balance, the star lives. But when the star's fuel runs out, the star cools down. The pressure inside it drops. This means gravity has won. It squeezes the star with all its might, and as a result, the star goes, hooray! In just 15 seconds, the brightest light you've ever seen in your life flashes, and our ex-Earth goes supernova, leaving a stunning nebula behind. Anyway, don't worry. It's actually impossible for a rocky planet to be the size of the Sun. Only other stars can be that large. But wait, why is our Earth so small while the other planets are enormous? Do they just keep growing, or do they stop at some point? The more mass you add, the more compression you get. As planets become more massive, the gravitational compression increases. They stop growing when their mass reaches roughly 1.7 times that of Jupiter, or 540 masses of the Earth. After that, adding more mass to a planet will make it smaller, because the compression becomes stronger. In other words, our little thought experiment is impossible.
Our good old solar system is actually a pretty bizarre place, what with all its out-of-this-world phenomena that we humans haven't managed to explain yet. There are rumors that a gigantic, undiscovered planet is hiding behind Neptune, volcanoes on Pluto spew ice, and a colossal canyon on Mars can accommodate the whole U.S. territory and most of Cleveland. Well, let's figure out if it's true by talking about the most mystifying solar system facts. The solar system is 4.6 billion years old. So old it's a senior solar system. Scientists came to this conclusion after they studied the oldest material they managed to get a hold of. And by that, I mean meteorites, of course. You won't be able to wear a hat on Venus, ever, and just try to stand on your feet. The planet is insanely windy. Its upper winds blow 50 times faster than the planet rotates. What's more, these fierce winds never stop and can get even stronger with time. Want to get away? You'll have to travel 11 billion miles away from Earth before ever leaving the solar system. Take your Google Maps with you. You probably heard of methane gas, a byproduct of natural processes such as volcanic activity and cows. Anyway, this gas is not only a part of the Martian atmosphere, but also the thing that confuses astronomers to no end. The thing is that the volume of methane on Mars keeps wavering, and scientists just can't figure out where it might be coming from. Can there be cows on Mars? As you may remember, Pluto used to be a planet but was stripped of this title in 2006. Later, it was reclassified as a dwarf planet. Gee, make up your mind. But the most unexpected fact about this celestial body is that its diameter is smaller than that of the US. See for yourself. The greatest distance across the country, from Maine to Northern California, is about 2,800 miles. As for Pluto, it's only 1,473 miles across. The planet Uranus, or Uranus, you can't win either way, rotates on its side, and astronomers have no idea why the planet has chosen such an unusual position. The culprits could be ancient mega-powerful collisions, but so far it's just a theory. By the way, this is the only planet laying on its side. Our Sun is insanely massive. Want some proof? Well, 99.86% of all the mass in the solar system is in the mass of the Sun, in particular the hydrogen and helium it's made of. The remaining 0.14% is mostly the mass of the solar system's 8 planets. Earth might not be the only tectonically active planet in the solar system. Astronomers have spotted some landforms looking like cliffs on Mercury. If it's so, the tectonic activity could explain the rapid shrinking of the planet. In most sci-fi movies about space, the main character gets into an asteroid belt and must dodge countless rocks that threaten to damage their spacecraft. Well, sorry to disappoint, but that's nothing like the real thing. The only asteroid belt astronomers know about is located between Mars and Jupiter. There are thousands of asteroids in this region, but they're so widely spaced that the chance of collision is next to nothing. You just ruined it. Sorry. Behind the orbit of Neptune lies the mysterious Kuiper Belt, filled with massive icy objects. The most curious thing about this space formation, though, is that scientists can't explain the pattern of its movement. The only explanation they have is that Neptune might be hiding a ginormous planet from our sight. This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed. Or not. Volcanoes on Earth are as different from those on Pluto as fire and ice, and I mean it. While we have volcanoes spilling lava on our planet, the volcanoes on Pluto spit ice. When frozen water expands, and this enormous pressure builds up until one day, bang, the ice erupts. In the process, a new cryovolcano gets formed. One of Saturn's moons, Lepidus, has a unique color. It's two-toned. One of its hemispheres is light and the other is eerily dark. Scientists haven't figured out this mystery yet. There's another weird thing about Pluto, or rather, about its atmosphere. First, it rises way higher above the surface of the dwarf planet than, for example, the Earth's atmosphere. What's more, the atmosphere on Pluto has more than 20 layers, and all of them are super cold and very condensed. We live inside the Sun. No, I don't mean that we're inhabitants of the red-hot ball of light approximately 93 million miles away. The thing is that the Sun's atmosphere stretches far beyond its visible surface, and our planet is right within its reach. In fact, it's the gusts of solar wind that create the breathtaking phenomenon known as the Northern and Southern Lights. The ocean on Jupiter is larger than any other on the rest of the solar system's planets. But wait! It's not the type of ocean you're thinking about. The one on Jupiter isn't made of water. This mesmerizing thing consists of metallic hydrogen, and its depth is a staggering 25,000 miles, which is almost the same as the circumference of the Earth. The Sun's atmosphere is hotter than the surface of the star. While on the surface, the temperature reaches 10,000 degrees Fahrenheit, the upper atmosphere heats up to millions of degrees. Scientists suspect that explosive bursts of heat from the Sun may have something to do with this unique phenomenon. People came to know about Saturn's beautiful rings in the 1600s, but only recently it became apparent that Saturn isn't the only ringed planet. All the gas giant planets, Uranus, Neptune, and Jupiter, have rings of their own, but they're thin and almost impossible to see. As for Mars, Venus, and Earth, they're made of rocky materials and have no rings whatsoever. Our solar system isn't the only one in the Milky Way galaxy. Far from it. The galaxy we live in houses about 100 billion solar systems. And if that's just our galaxy alone, can you imagine how many there are in the whole universe? At any given moment here on Earth, you can stumble across a rock that's arrived from Mars. After scientists analyzed the chemical content of some meteorites found in the Sahara Desert, Antarctica, and other places on our planet, they came to the shocking conclusion that they have a Martian origin. Since Mercury is the closest planet to the Sun, many people simply assume that it's also the hottest, and that's where they get it wrong, because, in fact, Venus, which is about 30 million miles further from the Sun than Mercury, is way hotter. The thing is that Venus has an incredibly thick atmosphere, which is 100 times denser than the one we have on Earth. On top of that, this atmosphere consists almost entirely of carbon dioxide, also known as a greenhouse gas. These factors make the temperatures on the planet rise to a staggering 875 degrees Fahrenheit, which is hot enough to melt lead. As for Mercury, its maximum temperatures reach only 800 degrees. Jupiter's moon, Io, exists in never-ending chaos due to hundreds of smoking volcanoes on its surface. If you ever visit this place, send me a postcard. Now, you'll see the smoke from these volcanoes billowing up high into Io's atmosphere. The most enormous volcano in the whole solar system, at least that we know of, is on Mars. The size of this monster is almost as great as the state of Arizona, and its height is as big as that of Mount Everest. How did it grow this huge? The answer is simple. There's much less gravity on Mars in comparison with our planet. Even if you're a tiny celestial body, you can still have a moon of your own. Hey, it's not that hard. In 1993, the Galileo probe was traveling past a miniature asteroid that was no bigger than 20 miles across, and discovered the little thing had a 1-mile-wide moon. Since then, astronomers have found tons of moons orbiting minor planets in our solar system. The valley called Valles Marineris on Mars is more than 10 times larger than Earth's Grand Canyon. And it's another thing that puzzles astronomers. After all, Mars isn't a planet with active plate tectonics. On the surface of Jupiter, there's a weird region that's called the Great Red Spot. Recently, astronomers have concluded that this spot is actually a storm that's been raging on the planet for centuries. But some 20 years ago, scientists noticed that the red region started to shrink. Nowadays, it's just half the size it used to be. And still, the spot is 1.5 times bigger than Earth. How about you? Do you know any other unusual facts about our solar system that I've missed? Then let me know down in the comments. If you learned something new today, then give this video a like and share it with a friend. But hey, don't go space traveling just yet. We have over 2,000 cool videos for you to check out. All you have to do is pick the left or right video, click on it, and enjoy. Stay on the bright side of life.
Our universe is full of both amazing and terrifying things. You already know about quasars, black holes, dark matter, and so on. But how about the horrors of space that you haven't even heard of? Would you like to visit the most bizarre worlds in the universe? And it's not me who made this list, but NASA themselves. Welcome to the Galaxy of Horrors, NASA's awesome Halloween collection. Please join me on a journey to some planets and tell me which ones you would consider the most horrible. Buckle up! Our first destination is a gas giant called TRES-2b. It's located 750 light-years away from us. If we used a regular spaceship, it would take us about 10 million years to get there. TRES-2b orbits a yellow dwarf, a star similar to our Sun. It also weighs about 1.5 times more than Jupiter. So, what's so special about it? Well, if you're afraid of the dark, you definitely don't want to visit this place. It's the planet of eternal night, the darkest one of all the planets known to us. But it's not that far from its star, so why is that? The thing is, the surface of TRES 2b reflects light even worse than coal does. Because of this, it seems that there's no light at all. If you were flying across the surface of this planet, it would be like walking with a blindfold on your eyes. Oh wait, actually there is some light. An eerie deep red glow surrounds the surface of the planet. This glow is created by the burning atmosphere, which makes TRES 2b a scorching planet. The air there is even hotter than lava. Oh, but if you think that was bad, let me show you the next place of our horror journey. NASA wasn't beating about the bush while nicknaming this one. Now, we're not just talking about one planet, but 3 at once. They're also located quite far away, 2,300 light years from the Sun. We would have reached them by ship in about 35 million years. All the planets are in the constellation Virgo, and each is extremely light, much lighter than the Earth. These 3 exoplanets are called Poltergeist, Dragger, and Phobator. Cool names, huh? It's because each of these planets is about to become a ghost soon. The thing is, they don't revolve around a star, but around a pulsar. Pulsars are rotating neutron stars with an extremely powerful magnetic field. In simple words, these are the stars that exploded one day. After the explosion, they usually emit such a powerful pulse that it causes the star to rotate at an unimaginable speed, several thousand rotations per second. At the same time, they constantly emit electromagnetic pulses that affect everything around them. So, you've probably already guessed what's happening with our zombie planets. They're slowly, gradually being destroyed under the gigantic influence of radiation. One day, they'll disappear without a trace. Ghost-like planets orbiting an undead star? Yeah, Zombie World is a fitting name. It's also not surprising that scientists nicknamed this pulsar Lich, despite the long official name. Well, at least these guys stick together on their final dance. This planet has a long name, so bear with me. HD 189733b. This gas giant is 65 light years away from us. It would have taken around 1 million years to get there on a spaceship. This planet is slightly more massive than Jupiter and orbits its star, an orange dwarf, all alone. At first glance, it may seem friendly. A pleasant blue color and curls on the surface. Kind of resembles a summer sky or foam on sea waves, right? Oh, looks are very deceptive, my friend. This planet has a pleasant cobalt blue color due to the hazy blowtorched atmosphere. This atmosphere contains silicates that condense when heated. In other words, the clouds on this planet have rain made of glass. Yes, it rains hot glass shards here. Oh, and if that's not enough, there's a raging wind on the surface, which is moving at a speed of 5,400 miles per hour. Just to compare, the fastest wind on Earth had a speed of 254 miles per hour, about 20 times weaker. And because of this, hundreds of thousands of glass shards rush horizontally across the planet's surface at breakneck speed. I really don't envy anyone who would want to try to land there. By the way, this isn't the only example of strange rains in our universe. For example, it rains molten iron on the planet Dimidium. Or let's take so-called carbon planets. Their existence hasn't yet been proven, but if they do exist, there would be tons of black poisonous clouds, and it would rain pure gasoline and hot liquid asphalt. Oh, and also, raindrops would explode upon touching the surface. Nothing special. The next planet, though, is actually really strange. It didn't just revolve around its star, it lived inside the star. This cosmic miracle is called Koi 55b, or Kepler 70b. This planet is very far away from us, 4,000 light years. It would take about 70 million years on a spaceship. It's twice as light as Earth and fully rotates around its star in just a couple of hours. A long time ago, it was an ordinary Earth-like planet about the size of Jupiter. It was peacefully and calmly orbiting its red dwarf star, Koi 55. But everything changed about 700 million years ago. Perhaps you've heard that in a couple billion years, our sun will begin to expand into a huge star, absorbing everything in its path? Well, this is the fate of red dwarfs. Sooner or later, they increase, turning into incredibly hot blue giants. The same thing happened with Koi 55. This star began to increase in size and heat up in temperature, gradually turning into a blue-white giant. It was ready to devour its nearest planets, but Koi 55b didn't care about it. When the star reached it, this planet just settled inside. And moreover, after some time, it left its star, simply returning to the new orbit. How was that even possible? Life inside its star turned Koi 55b into a red-hot round stone. It's one of the hottest planets we've discovered so far. The temperature on it reaches 12,000 degrees Fahrenheit. It's hotter than the sun, which is, let me remind you, an actual star. And for some reason, it's still alive and lives as if nothing happened. Unfortunately, sooner or later, the planet will disappear anyway. It's slowly evaporating itself due to the incandescent atmosphere. But still, it somehow managed to survive the journey through the star, which isn't typical for regular planets, to put it mildly. I envy this willpower. However, not all planets are so lucky. Some are gradually being destroyed by their stars, and there is even an entire system among them. This last planet is a sad loner. It's located 870 light-years away from us. The journey by ship to it would take about 25 million years. This planet is about 1.5 times more massive than Jupiter. This is a very sad, dark planet. A doomed gas giant, which is very similar to hot Jupiter, orbits its star all alone. At the same time, it's located so close to its star that its orbital period takes just 1 day. Of course, because of this proximity, the star gradually absorbs WASP-12b. The scorching heat of the star is slowly destroying and devouring the planet's atmosphere. The planet has only around 10 million years left. But what's more interesting, because of this stretching, WASP-12b acquired the shape of an egg. It doesn't even resemble an actual planet anymore. It's also very hot. The surface temperature of the gas giant reaches 4,000 degrees Fahrenheit. Also, a spectrograph of cosmic origin, or COS for short, found that the planet exchanges matter with its star. They're located so close that they give each other part of their chemical elements. This is a common phenomenon in closely spaced binary star systems, but this is the first time scientists have seen this in a star-planet relationship. What a unique system. To be honest, if I was guaranteed complete security, I'd be excited to visit at least some of them. What about you? Please let me know in the comments. Scientists keep finding new planets they call super-Earths. It's a class of more massive planets than Earth, but way lighter than ice giants, such as Uranus and Neptune. Super-Earths can be made of rock, gas, or a combination of these two. They are often twice or even up to 10 times bigger than the Earth. They're interesting to study, but kinda too far away from us. They're pretty common outside of our solar system, together with other interesting planets like mini Neptunes. Those can also be gas dwarfs, ice giants, or huge rocky bodies. But again, we don't have anything like that. But something we do have that those other solar systems don't? Jupiter. It's the biggest and heaviest object that orbits our sun. This king of planets possesses a powerful force to dominate our solar system. Jupiter is notorious for eating planets. A protoplanet slammed into it about 4.5 billion years ago, when Jupiter was still a young planet in its early stages. This protoplanet was 10 times heavier than Earth and was made of ice and rock. The collision was huge. Jupiter's core broke apart, and helium and hydrogen mixed with denser materials. Through time, the heavy material settled back into the dense core, which is what we see today. And if it swallowed a planet before, it might keep doing it as well. We suspect our solar system used to have many more large planets than it has now. For example, it's kinda empty around Mercury today. Similar areas around many other central stars are definitely more packed with intermediate mass planets, with the size between Earth and Neptune. Our solar system was a chaotic place at its beginnings. Young stars were surrounded by swirling disks of dust and gas, and planets would form out of that debris, something like trees when they're springing up from the ground. Small rocky planets would form in the strong heat and light close to stars, while gas giants would form farther out, where temperatures were lower, which means they could preserve more gassy materials. And even though planets in our solar system seem pretty stable and peaceful today, following their orbit, they weren't that calm before. Some planets didn't have a circular orbit. They had oblong, more eccentric paths. It took them swinging first toward their stars and then farther away. It was like they had been thrown off kilter by the gravity of other planets on their way. There's something called the grand tack theory. It explains things happening in the first few million years when our solar system was forming. At some point, Jupiter, one of the key players here, may have been pulled in closer by our central star. After that, it went back and took a huge cloud of debris. It was like a sailboat when it tacks around a buoy. This kind of messed with planets that were in the process of formation. After Saturn was fully formed, our close neighbors in the solar system cleared out a little. But if the idea about grand tack is correct, Jupiter had grabbed everything in its way, and its migrations had caused more collisions in this area. Jupiter might have delivered some of the water that now fills the oceans we have on our planet. It shepherds plenty of asteroids. From time to time, it sends some whizzing into interstellar space, or amongst the planets in our solar system. It may have even taken part in the dinosaur extinction 66 million years ago. When the huge space rock hit the Earth, it left a crater off the coast of the Yucatan Peninsula in Mexico. It all caused earthquakes, volcanic eruptions, and tsunamis that made a huge impact on all animal and plant life on Earth. No one knows where it came from. We're not even sure if it was an asteroid or a comet. One theory says it may have been a comet that came from the Oort cloud, which is made of icy debris and is located somewhere at the edge of our solar system. It could have been bumped off course by Jupiter and its powerful gravitational force. This way, our solar system was like a pinball machine, where Jupiter, the biggest planet, kicks incoming comets into orbits that send them closer to the Sun. When these comets are near the Sun, they can go through strong tidal forces that break them apart and eventually create shrapnel-like pieces of a comet. That event was a point when our mammalian ancestors started to rule. That means without Jupiter, there might not be us either, nor the Earth. It seemed like our biggest planet came swinging in, destroyed older planets, and cleared the way for smaller worlds like ours. Jupiter may have been the reason why we can't find Planet 9 right now. Scientists believe it exists, and they think it could be hiding somewhere beyond Neptune, but not Pluto. There are 3 zones in our solar system: the inner planets, outer planets, and whatever there is beyond. The mysterious planet could be the size of the Earth or Mars. It swirled among the gas giants before they eventually swept it toward the outer parts of our solar system, or even somewhere into deep space. Jupiter has stripes because of differences in temperature, atmospheric gas, and chemical composition. Scientists used to think the only reason for these different colors was the mighty atmospheric wind and material circulating between layers of the atmosphere. Now we know the light-colored stripes, or so-called zones, show us where the gas rises. When the stripes are dark-colored, they're called belts and can tell us where gas is sinking. Jupiter's moons could also be why the planet is stripy, because they're tugging on its atmospheric convection cells. At the center of Jupiter, there's a dense liquid core made of helium and metallic hydrogen, together with dissolved heavier elements. As we go further from its center, the temperature and pressure inside the planet drop off. That way, the liquid interior gives way to gases from the atmosphere. Again, mostly helium and hydrogen. No one knows how deep this liquid-gas boundary lies, but the planet is probably fully liquid a couple of thousand miles under its cloud tops. Jupiter would still be bigger than some other giants, like Saturn, if we could strip its gases. Jupiter is sometimes even called a failed star, although that's not quite correct. It's mostly made of hydrogen, like regular stars, but it's still not massive enough to start thermonuclear reactions in its core, which would eventually turn it into a real star. In theory, every object could be turned into a star if you only add enough matter to it. If there's enough mass, the temperature and internal pressure will increase and start thermonuclear reactions. So, to turn Jupiter into a star, such as the Sun, you'd have to make it 1,000 times more massive, But to form a cooler red dwarf, you'd only need 80 Jupiter masses more. That way, Jupiter won't spontaneously become a new star of our solar system. But if many space objects with similar mass collide with it, or in other words, if Jupiter eats them, then maybe. You never know. But in theory, if it could become a massive star, it would have stopped other planets from forming in stable orbits. It would have also increased the radiation that the surface of those planets get, which is why it would be really hard for life to develop in our solar system. Jupiter is the planet that spins the fastest in our solar system. It only needs 10 hours to make a full rotation on its axis, even though it's huge, more than 300 times bigger than the Earth, and 2.5 times more massive than the rest of the planets in our entire solar system together. But if it got more massive, it would shrink. More mass would make Jupiter denser, which means it would begin pulling in on itself. So it could get 4 times its mass and would still be the same size.